Hi everyone, my name is Thomas Kim. Today is May 8th, 2023. The lady on my desktop looks very sad. Her eyes are full of tears, but I am very happy today because I have read OpenGL Programming Guide 9th edition. In this book, Chapter 6, Texture and Frame Buffers. This texture chapter is very complex. I carefully read chapter 6, but I could not understand. I could not understand at all. Everything looked so complex. So I read OpenGL Super Bible from this book. I also read chapter 5, section Texture. Even though I read this section very carefully, I still could not understand how to use OpenGL texture until I created this song. When something that you want to learn looks very complex and overwhelming or baffles you completely, then create a song and memorize it blindly. Then, as you gain more experience, you can begin to understand those things that you memorized blindly. For example, create textures, bind texture, text storage 2D, text up image 2D, find the texture you need. After memorizing this song, I now begin to understand how to use textures in OpenGL. Even though you read the books very carefully, you can still fail to understand correctly because the book can leave many things unexplained. I would highly recommend you try the sample code of the book. For example, Chapter 6. This is sample code for Chapter 6 about static texture. Control F5. This seems to be working properly. I examined this code very carefully. In this section, I will modify it FF. So this corner should be white color. In this part, I will modify it 00, 00. Now press Ctrl F5. Obviously, the image is not what I expected. Top right corner is black, but I specified. At the left bottom, I specified black color. Top right corner, bottom left corner, they are inverted, reversed. So something in this algorithm is wrong. If you watch through my current video, you will have solid understanding textures in OpenGL, so you can prevent such mistake in your future OpenGL programming. Without further ado, let's get started. Open up Visual Studio Code, Electricity and Magnetism. Click this button, 066. Texture, Swizzle. Click this button, Swizzle.cpp. Click this button, Swizzle.but. Click this button, Swizzle.preg. Click this button, debug.txt. Ctrl V. We created 1, 2, 3, 4 blank files. Select Swizzle. If you can memorize these three songs, you can create OpenGL program from scratch. For example, create vertex arrays. Find the vertex array. Enable vertex attrib array. Vertex attribPointer. Create buffers. Name the buffer stories. Find the buffer to its target. Create textures. Find texture. Text stories 2D. Text of image 2D. Find texture unit. Create vertex arrays. Bind vertex array. Enable vertex attribute array. Vertex AttribPointer. Create buffers. Name the buffer stories. Bind the buffer to its target. Create textures. Bind the texture. Text stories 2D. Text of image 2D. Find texture unit. If you pack these seemingly stupid songs or commit them to your memory, you can pull up them and fire whenever OpenGL frightens you. You will never get lost in the jungle of OpenGL. Now I will hold it up. Include CPG, STD extensions. Include OpenGL Programming Guide 9. Begin app declaration. We need class name. Text Swizzle. This will be our class name. And app declaration. Define app, copy this class name and paste it here. We provide the title, texture, Swizzle. In this section, private, public. In the debug.txt, Swizzle.cpp or d.exe, qstd, C++20, md, d, ehsc, app, no, SQL, link, subsystem, console. Open up this command prompt. Ugly bug. You should have Interleaved OpenGL Programming Guide 9th edition. This message dir cd 066 texture Swizzle icxcl at debug.txt. Hit enter. cls d. You should be able to build successfully. Now I will close it. Select begin app declaration. Right click, go to definition. If you scroll up, you can find initialize. Copy up to resize. Paste it in the public section. Copy virtual. Control H. Replace all. Override. Here also override. Here also override. Then make block. It should be override. If you build and run, it does not work. cls d. It does not work. Control C. We have to call base. Initialize title. If we rebuild, it does not work. cls d. It does not work because I made a syntax here. This become go to target. Once again, this become go to target. It is calling recursively. I missed one more colon here. You have to fix like this. Now it'll work. CLS D. It now works perfectly. So don't miss 1 colon. You have to use 2 colon to call base definition. Defined here, we have to call initialize defined in the base class. Now close it. We define vertices, static constant, GL plot, vertices. This is array. Don't miss semicolon here. This is for OpenGL Vertex positions in the frame buffer. I will draw like this. In OpenGL frame buffer, this coordinate is -1, +1. This coordinate is +1, +1. This coordinate is -1, -1. This coordinate is +1, -1. So here is the center 0, 0, the origin. Now 0.75 f, 0.75 f. This represents positive, 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 positive. So right top vertex position, positive 7.5, positive 7.5, positive 1, positive 1, right top vertex position. Copy, paste, paste, paste. Now it should be left top coordinate. Left top coordinate should be negative, positive. So it should be negative to be left top coordinate. Now left bottom vertex position to be left bottom, it should be negative, negative. So negative, negative. I will arrange like this. Then right bottom, right bottom to be right bottom coordinate. It should be positive, negative. So it should be negative. Please understand, right top, this is right top, our starting vertex position. Then close to the left top, to the left top. So it flows this direction from left top to left bottom. So it flows downward from left bottom to right bottom. So it flows to the right direction. This direction, this direction, this direction forms counterclockwise orientation. This is default winding up orientation. You can use either counterclockwise orientation or clockwise orientation. The default is counterclockwise winding up orientation. Now OpenGL texture coordinates. You have to be extra careful. I will draw like this. This is 0.0. This is 1.0. This is 0.1. This is 1, 1. In our vertex position, this is the starting vertex. So we will also start from here, and we should flow in the same direction. In this direction to the right, upward. upward. We started left top vertex position, so 1, 0. Right top texture coordinate. Copy, paste, paste, paste. It should be left top. This is left top. So it should be 0, 0. Now left bottom. Left bottom. This is left bottom. 0, 1. Now right bottom. This is right bottom. So 1, 1. Remove trailing comma. This is right bottom texture coordinate. We have to match vertex positions orientation with texture coordinate orientation, winding up direction. If you don't match these things, you will have many unexpected errors. Now I will fold it up. Static const gl unsigned byte text cells semicolon 0x ff in decimal 255 is the full intensity for color red when the external format GL red is specified. You may not understand what is the external format. The external format means the memory layout on the client or CPU storage. 0x ff. This is full intensity for color red and is 1 byte, a single byte. 0x 00. This is 0. Copy, paste. Now 4 byte, 6 byte, 8 byte. 0x 00, 0x ff. 2 byte, 4 byte, 6 byte, 8 byte. In total 16 byte. Paste, paste, paste. I will arrange like this. Remove trailing comma. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 by 8 text cells or texture elements. Now I will fold it up. Now I will select Swizzle but and arrange Swizzle flag side by side. Version 460 core. Layout location 0 in back 2 V position semicolon. Layout location 1 in back 2 T position for vertex coordinates. For text cell coordinates. Out vertex shader out. Back to text code. Don't miss semicolon. Void main GL position. Back 4 V position 0 1. Text code. We simply pass T position in the Swizzle.flag version 460 core. Out back 4 color. I will copy this and paste it here. It should be in. Layout binding. I will use 2. Uniform sampler 2D text 2D. Void main, we will output color by reading texture element from text 2D at the texture coordinate. We read in the text cell value from text 2D, the sampler 2D, and assign it to output color. With this, in the Swizzle.cpp program, create program, we pass Swizzle.but, Swizzle.preg. Of course, we have to declare gluint program. If you right-click, create program, go to definition. In this section, you can find create shader program. Go to definition. We created this program in our previous episode. For example, on episode 77, if you control-click by watching this video that I filmed over 2 years ago, you can learn how I implemented create program. Now select Swizzle Vertex shader. To activate V position and T position, these are Vertex attributes. We need Vertex array object. glUint Vertex array object. We need it to activate Vertex attributes such as V position and T position. glUint Vertex buffer object to hold GPU storage for our Vertex attributes. glUint text 2D texture object. glUint sampler 2D to set properties of the texture sampler. Now we need OpenGL Vertex song. Create Vertex arrays, bind the Vertex arrays. gl create Vertex arrays. 1 Vertex array object. gl find Vertex array. VAO Vertex array object. Now we will create buffer to hold OpenGL vertices. I will fold it up. Create buffers named buffer storage. gl create buffers Vertex buffer object. Create buffers named buffer storage. gl named buffer storage. Buffer is this. It is named size of this memory size. Data vertices flag we will set 0. Of course, we need gl find buffer. We will use gl array buffer Vertex buffer object. Create buffers named buffer storage. Bind the buffer to its target. Create Vertex arrays. Bind the Vertex array. Enable Vertex attrib array. VertexAttribPointer. gl enable Vertex attrib array. So we enable V position by providing location 0. VertexAttribPointer. VertexAttribPointer. index, v positions, location. Once again, 0. If it is confusing, then you can create enumeration like this. enum v position. It represents v position, v positions, location 0. Then t position. We created simple enumeration. Then in its place we can say v position. This is v position. I missed I, the typo here. So v position semicolon. Usually vertex attribute pointer should come prior to enable vertex attribute array. Now vertex attribute pointer size for vertex position we pass 2 elements, so it should be 2 type gl plot, normalize gl pulse, stride 0. This represents offset, offset null. Now copy, paste. We will enable texture position. Its index is 1, so it should be 1 and 1. But we defined enumeration t position for location 1, so in its place we pass t position, t position. Everything is the same, but for offset. This is for offset. Offset means from the start of a vertex array to the first element of texture coordinate 1, 2, 3, 4, 5, 6, 7, 8 plots. So it should be 8 times size of gl plot. Instead of doing this copy, I will use gl int ptr offset. Then 5 times size of gl plot. I will copy this, paste it here. It should be void pointer. I can say offset for text cell coordinates. Copy, then paste. Now it's clear. Before we move on, I have something to confess to my audience. Until recently, I did not understand how this VAO or vertex array object and this VBO or vertex buffer object, also V position and T position, V position and T position or vertex attributes, how vertex array object, vertex buffer object, vertex attributes working together. Until recently, I didn't understand how all these things work. Now I completely understand how all these things, vertex array object, vertex buffer object, vertex attributes working together seamlessly. Only recently I come to understand it completely. Then how? The answer is in the sampler 2D or texture. We need OpenGL texture song. Create textures, find texture, text stories 2D, text sub image 2D, find the texture you need. By using this texture, I could understand how vertex buffer object works. Now we will create texture object. for our sampler 2D in the Swizzle.fragment. GL create textures target GL texture 2D 1 text 2D create textures find texture text stories 2D text of image 2D find texture unit GL find texture we find texture target texture 2D GL text stories 2D target GL texture 2D labels. Please notice this is plural. For. I will explain what for means. I will make it bigger. When we create text cells, we defined 8 by 8 text cells. So here 8 by 8 text cells. This is level 0. From this we can create 4 by 4 level 1. From this 2 by 2 level 2. From this 1 by 1 level 3. So we will generate 4 min-maps. Then internal format GL RGB8. We will use RGB alpha channel. It can be RGB8. R is 8-bit. G is 8-bit. B is 8-bit. A is 8-bit. 8-bit port channel. Then width 8, height 8. GL generate texture min-map. This is texture. This texture. We now generate min-maps. These are min-maps. Level 0 or 8 by 8 is called base level. Indexed 0. From our text cells, 8 by 8 text cells, we generate 4 by 4, 2 by 2, 1 by 1 min-maps. MIP maps 4 by 4, 2 by 2, 1 by 1 will be generated. For your information, MIP stands for multum in favo in Latin. It means many details in small space. Create textures, find texture, text stories 2D, text of image 2D, find texture unit, GL, text of image 2D, target, GL, texture 2D, level. This is singular. It means base level. Offset 0. Y offset 0. Width 8. Height 8. Now format. This is external format. GL red. The external format or CPU memory layout. Then type. Scroll up. We defined our text cell using GL unsigned byte. So here it should be GL unsigned byte. Then text cells. Now we finally consume text cells. Here, semicolon. I will give you more explanation about this part shortly. Now we have the last line of our texture song. Create textures, bind texture, text stories to the text of image to the bind texture unit. So we have to bind our texture unit. GL bind texture unit. We bind our text to the sampler to the texture text 2D in fragment shader. Its binding point is 2, so 2. I missed D. Don't get confused. Bind texture unit with bind texture. There is a huge difference. I will also explain what is the difference between GL bind texture and bind texture unit. I will explain what are the difference in my current or in my next episode. Now I will make it bigger and copy and paste this link. If you control click, you can open this document, glTextureParameter. This document looks very complex. Actually, this document is very simple. We have glTextureParameter. glTextureParameter is supported since version 2 of OpenGL. glTextureParameter is supported since version 4.5. When two different versions are supported, always prefer latest version. So we will be using glTextureParameter. glTextureParameter I. Texture. We provide our texture object here. Then enumeration parameter name. I'll be using glTexture base level. Our base level is 0. glTextureParameter I. Text 2D glTexture max level. Our maximum min-map level is 4. If you are uncertain in this document, search for glTexture max level. Set the index of highest defined min-map level. This is an integer value. Initial value is 1000. I think we can set 3 because base level is 0. Highest level is 3. So it should be 3. Now glTextureParameter I. Text 2D. We will use glTexture Swizzle RGBA. We specify Swizzles. I haven't defined Swizzles yet. Static constant glint Swizzles. This is array semicolon. Now glred gl1. If glred is 0xff, this becomes 0xff, 0xff. Then this value will be expanded to 0x01. This is RGBA. If you scroll up, when we call text storage to the, we specified internal format RGBA. The color value in the GPU storage or internal format. So from external format와 CPU memory layout, we copy value red. If our value red is 0xFF, we create new color value for internal format와 color in GPU memory. I will copy it once again. If red is 00, then it becomes 00, 00, 00, 00. Why is giggle? Sorry, it should be integer vector. I will disable it for the time being. We will enable it a short while later. Now GL create sampler 1, sampler 2D, GL find sampler unit. This unit means sampler text 2D is binding point, so it should be 2. Then we bind our own sampler, GL sampler parameter I, sampler 2D, GL texture magnification filter. Please understand, this is not maximum filter. This is magnification filter. We use GL near list. We will learn about this in my next episode. Copy, paste, GL min filter. Now, with this, in the function display, GL use program, static, GL plot, background, 0, 3F, 0, 3F, 0, 3F, 1.0 F. We can use static const, GL clear buffer FB, GL color we draw buffer. Draw buffer is default 0. Then background, erase the background, GL draw erase, GL triangle fan. First 0 count 4. We have to swap buffer. With this, we rebuild CLS D. Obviously, this is red color. Now, close it. We will now enable this part, texture Swizzle. If our red color is FF, then using this format, FF, it becomes white color. If our red color is 00, then it becomes 00, 00, 00, 00. It becomes black color. This is white, this is black. Now scroll up. In this case, it becomes white color. In this case, it becomes black color because this 0FF is red. This 00 is red. This is GL red. It will be expanded 0xFF, 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 then 0x01. If this is GL red, then it will become 0x00, 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 0x01. So this is white, this is black. These are called texel Swizzle. We specified texel Swizzle in this part. Our formula is red, red, read GL1. With this, we rebuild CLS D. It is perfect. Now close it. Scroll up. Now we can make it more interesting. Also, copy this, paste it here, also paste it here. We rebuild CLS D. Perfect. At this corner, right top corner, we specified white, 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 white. At the lower left corner, black, 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 black. It works perfectly. In my next episode, we will do lots of experiments. Also, I will explain how VAO or Vertex Array Object, VBO or Vertex Buffer Object, how Vertex attributes work together. Also, we will have more experiment with the texture.